Let's do some dynamics. We'll go through 7 questions in this video. How much friction force will a car generate if we know its mass and frictional coefficient? How do we calculate acceleration using force and mass? Keep watching to find out. Question 1. A bird with a mass of 0.8 kilograms is accelerating at 3 meters per second squared. What is the magnitude of the net force on the bird in newtons? Step 1. What variables have we been given? The first variable that we have been given is mass, which has the symbol m, and its value is 0.8 kilograms. The second variable we have been given is acceleration, which has the symbol a, and its value is 3 meters per second squared. Step 2. What variable have we been asked to find? We have been asked to find the magnitude of the net force, which has the symbol F, units of newtons. Step 3. Find the equation that has all of our variables. We need to find an equation that contains the variables F, M, A. That would be this equation, or F equals MA. Step 4. Substitute our values into the equation. Let's substitute our numbers into the equation. Force equals 0.8 times 3. If we plug that into the calculator, 0.8 times 3, then we get an answer of 2.4 newtons. Question 2. An 800 kg car is traveling at 20 kilometers per hour when the brakes are applied. The brakes exert a constant force of 5,000 newtons backwards on the car. What is the magnitude of the acceleration of the car while the brakes are being applied? Meters per second squared. Assume there are no other forces acting on the car. Step 1. What variables have we been given? We have been given a mass of 800 kilograms. Velocity is 20 kilometers per hour. We will have to convert this into meters per second. You simply divide by 3.6. 20 divided by 3.6 is 5.5556. And note that we round it to 5 significant figures. Next, we have been given a force of 5,000 newtons, and it is in the opposite direction to the velocity of the car, so it should be a negative number. So F is equal to negative 5,000 newtons. Step 2. What variable have we been asked to find? We want to find the magnitude of the acceleration. So A is equal to question mark, meters per second squared. Step 3. Find the equation that has all of our variables. We have the variables mass, velocity, force, and we want to find acceleration. To find acceleration, we only need mass and force in this example. Velocity is not necessary. You will find that you may be given unnecessary variables in your problems at times. With experience and a good knowledge of the equations, you will begin to recognize when a variable is not necessary. So the equation that contains A, M, and F is the same equation as before, F equals MA. We need to rearrange for A. We can divide both sides by M. If we do that, we get A equals F over M. Step 4. Substitute our values into the equation. A is equal to negative 5,000 over 800. We put that into the calculator. Negative 5,000 divided by 800, we get negative 6.25, which rounds to negative 6.3. We just wanted to know the magnitude of acceleration, so the answer is 6.3 meters per second squared. Question 3. An apple has a mass of 500 grams and is stationary on a horizontal table. Which of the following is true? This is a question format that you are likely to come across, where you are asked to select a statement that is true or false. My strategy for this is to go through each option and determine whether they are true or false. Even when you find the answer, make sure you go through the rest of the options, make sure you haven't made a mistake. Let's look at the first statement. Option A. The weight of the apple is 0.5 newtons. In physics, Weight has a different meaning to the way we say weight in everyday life. In everyday life, if someone asks me what my weight is, I say 72 kilograms. However, in physics, weight is a force that a mass exerts due to gravity, and force is measured in the unit of newtons. Therefore, instead of saying 72 kilograms, I would say that my weight force is equal to 720 newtons if we assume that G has a value of 10. The equation for weight force, or F with a subscript of W, Fw, is mass times gravitational acceleration, or F equals mg. For PHSI191, the value of G that you use is 10 meters per second squared, which makes calculations a bit easier. We know that the mass of the apple is 500 grams. We need to convert this into kilograms by adding a kilo prefix. Remember that the kilo prefix represents 10 to the power of 3, or 1000. So to add the kilo prefix, we simply divide by 10 to the power of 3, or 1000. 500 divided by 1000 is 0.5, so m is equal to 0.5 kilograms. Now let's substitute our values into the equation. The weight force is equal to 0.5 times 10. We get an answer of 5. So we know that option A is false, as the weight of the apple is 5 newtons. Let's look at the second statement, option B. The table is exerting a normal force of 5 newtons on the apple. To answer this question, we must understand what the normal force is. In physics, normal means perpendicular. The normal force is a contact force exerted by one object on another object perpendicular to the surface in contact. So we have already established that the weight force of the apple is 5 newtons. This weight force will be the force that is applied by the apple to the table vertically downwards. Newton's third law states that for every force, there is an equal and opposite force, or a reaction force. So if the apple is pushing on the table is also pushing on the apple. This is the normal force, and the magnitude of this normal force will be equal to the weight force of the apple. However, the direction will be opposite, directed vertically upwards. Therefore, the normal force exerted by the table on the apple will be 5 newtons, and so this statement is true, and option B is our answer. Even though we found our answer, you should continue to evaluate the other statements to ensure that you haven't made a mistake. Let's look at the third statement, option C. There is a net force on the apple that is not equal to 0. The net force on an object is the sum of all the forces that are acting on that object. Newton's first law states that an object at rest remains at rest, and an object in motion remains in motion unless subject to a net force. What this means is that if the net force on an object is 0, its velocity will not change. We have been told that the apple is stationary, so we know that the net force on it must be 0. We have already done the calculation where there is a weight force on the apple of 5 newtons going down, and an opposite force of 5 newtons from the normal force going up, which cancels out. Therefore, option C is false. Let's look at the fourth statement, option D. The apple is accelerating at 10 meters per second squared. We know that the apple's velocity is 0, and this velocity is not changing. Acceleration is equal to change in velocity over time. So if there is no change in velocity, acceleration will be 0. Therefore, option D is false. Let's look at the last statement, option E. The apple exerts a downward force of 5,000 newtons on the table. We have already established that the apple exerts a downward force of 5 newtons on the table. Therefore, option E is false. Question 4. A car with 4 wheels in contact with the ground has a mass of 1200 kilograms and the frictional coefficient between the car's tires and the ground is 0.8. How much friction force can the tires generate together in newtons? Treat all 4 tires as one object. Step 1. What variables have we been given? We know the mass, m, is equal to 1,200 kilograms. The frictional coefficient has the symbol mu, and this is equal to 0.8. The frictional coefficient tells us how much friction there is between two surfaces. The higher the value, the more friction there is between two surfaces. The highest value is 1.0. For example, a car tire on asphalt has a frictional coefficient of 0.8, whereas a car tire on grass has a frictional coefficient of 0.35, almost half. The same car tire on ice has a frictional coefficient of 0.1, meaning it is very slippery, and not a lot of friction force can be generated. Step 2. What variable have we been asked to find? We want to find the maximum value of friction force, which we can write as F with subscript F. Max friction force equals question mark in newtons. Step 3. Find the equation that has all of our variables. We need to find an equation that contains friction force, mu, and m. The equation that we'll use is frictional force equals frictional coefficient multiplied by mass times gravity, or F equals mu times mg. Step 4. Substitute our values into the equation. Friction force equals 0.8 times 1,200 times 10. If we plug that into the calculator, we get an answer of 960 newtons. Question 5. A box stationary on a table requires 20 newtons of force to be applied horizontally before it starts to slide. The frictional coefficient between the box and table is 0.6. What is the mass of the box in kilograms? Step 1. What variables have we been given? We know the maximum frictional force that can be generated is 20 newtons. So max friction force equals 20 newtons. The frictional coefficient is 0.6. So mu equals 0.6. Step 2. What variable have we been asked to find? We have been asked to find the mass of the box, so m equals question mark in kilograms. Step 3. Find the equation that has all of our variables. We can use the equation friction force equals mu times mg. We need to rearrange for mass, so we'll divide both sides by mu and g. The new equation is m equals friction force over mu times g. Step 4. Substitute our values into the equation. Mass equals 20 over 0.6 times 10. If we plug that into the calculator, use the fraction button, enter 20, then arrow right or down, then enter 0.6 times 10. This gives us an answer of 10 over 3. We can press the SD button to change this to a decimal number. This gives us an answer of 3.3 kgs, rounded to two significant figures. Now let me also show you why I like to use the fraction button. I want you to enter in 20 divided by 0.6 times 10. You will get an answer of 333.33. This is wrong, but why do we get this answer? Because multiplication and division have the same priority order of operations in a Casio calculator. It will simply perform calculations from left to right. So it will do 20 divided by 0.6, which is 33.33, then multiply this answer by 10. If you wanted to get the right answer while inputting the numbers on one line, then you would have to explicitly tell the calculator to do the 0.6 times 10 first by putting this in parentheses. I think it is simpler to use the fraction button rather than using parentheses. The chances of making a mistake with parentheses are higher in my opinion. It's all about creating systems where you are less likely to make mistakes. Question 6. A box with a mass of 5 kilograms applies a force of 10 slide horizontally or it starts to slide on a table made of wood. What is the frictional coefficient of the box and the wood? Step 1. What variables have we been given? The mass is 5 kilograms, so m equals 5 kgs. Max friction force 10 newtons. Step 2. What variable have we been asked to find? We want to find the frictional coefficient, so mu equals question mark. The frictional coefficient is a ratio, so it doesn't have any units. Step 3. Find the equation that has all of our variables. We can use the same equation, friction force mu times mg, but we need to rearrange for mu. So we can divide both sides by m and g, which gives us mu is equal to F over mg. Step 4. Substitute our values into the equation. Mu is equal to 10 over 5 times 10. Putting this into the calculator, fraction button, enter 10, then arrow right or down, then 5 times 10. The answer will be 0.2. Question 7. A 140 kilogram strongman pushes a bus with a mass of 3,000 kilograms. The strongman and bus are accelerating at 0.60 meters per second squared. The strongman exerts a frictional force of 2004 newtons on the ground. What is the magnitude of the frictional force exerted by the ground on the bus in newtons? These sorts of questions can be quite hard to juggle in your head, so I find it helpful to draw a diagram to help me visualize the situation. I'm not a good drawer, and even if you are, I don't suggest spending a lot of time on making pretty diagrams. I just draw stickmen or boxes to represent my objects. So let's draw a stickman pushing a bus, which is represented by this box. Both objects are in contact with the ground, which provides friction force to both objects. For this question, it is easier if we treat both the strongman and the box as one object, because they are both accelerating at the same rate. Let's draw a circle around them, to signify that they are one object. The mass of this object is 140 plus 3,000, so 3,140 kilograms. We know that it is accelerating at 0.6 meters per second squared. Now let's draw the force vectors acting on this object. We have been told that the strongman is exerting a frictional force of 2004 newtons on the ground, and this will be directed to the left. Frictional forces act parallel to the surfaces of contact, so it will be horizontal. The ground will exert an equal and opposite force on the strongman, so there will be a 2004 Newton horizontal force to the right on the object. Let's call this force 1. If we were to calculate the acceleration using this value, then we would get A equals F over m, or 2004 divided by 3140, which equals 0.64 meters per second squared. However, we have been told that the bus and strongman are accelerating at 0.6 meters per second squared. So there must be a force in the opposite direction. This will be the friction force of the ground on the bus resisting the motion of the bus. Let's call this force 2. This is what we need to find. We cannot find the frictional force of the ground on the bus directly. However, we can use acceleration and mass to calculate the net force. So we will use net force equals ma. Net force equals 3,140 times 0.6. Plug that into the calculator and we get 1,884. The frictional force backwards or to the left must be the difference forwards force and the net force. Remember that net force is the sum of all the forces acting on the object. So we can say net force, or F net, is equal to F1 plus F2. If we rearrange for F2, by subtracting F1 from both sides, then we get F2 equals F net minus F1. F2 equals 1884 minus 2004. If we plug that into the calculator, then we get an answer of 120 newtons. And that is the force that the ground is exerting on the bus from friction. So that's it for dynamics. Try solving these problems on your own to see if you remember how to do them. If you get stuck, you can refer back to my videos. The next section will be on mechanical energy. How much kinetic energy does a dog have running at 12 meters per second? What is the velocity of a child after going down a 3.2 meter frictionless slide? Find out in the next video.